Students, okay, this is our Himanshu Pandey advanced problems, very easy if you listen. And this is the fourth part, already GOC 3 parts uploaded, and there is a playlist also you can check in our channel Keshav Waves. You can check here. Out of these 4 compounds, they are asking correct CN bond length, where between C and N bond length is maximum, minimum. They are asking this kind of order. Okay. You have found that these are the options there. See, lone pair, one sigma bond, benzene pi bond is there. This is called conjugation, right? So this lone pair will come inside of the benzene ring and this bond will break. Okay. And because of this extra one more C double bond OH to the benzene, one of the resonances, this O also involve. Got it? Here you can check. Here resonance similar way is there, but it's only plain benzene ring. So this is the group compared to second option. This is the group making lot of time the lone pair is coming towards the benzene. So here it is not a single bond, there is a double bond character. But here also not a single bond, double bond character. But here aldehyde is making more time the lone pair into benzene ring. So here compared to second option, first option has more double bond character. Okay, and you can find the fourth option. Here all the time double bond only is there. This double bond don't become single bond here. So more number of bonds, less bond length. So here least bond length is there. And here lone pair is there. This lone pair never following or involving the resonance because no pi bonds here, always single bond. So always single bond is more in length, always double bond least in length. Double bond character, they are intermediate, yes or no? Therefore you can find here what type of answer you may give. Third, always single bond, so it has longest bond. And fourth, always double bond, no resonance, it is shortest bond. So 3 highest length, 4 least. For example, here is there, here also is there. Now is it the bond length 2 greater than 1 or 2 less than 1? Here I said this aldehyde group extra pulling capacity is there. Here more double bond character is there. Therefore it is less length when compared to 2. So 2 bond length is more than 1. So your option is third option. The next question, students. Here between C1 and C2 bond is shortest. Which one is shortest? See, everyone carbon, 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 carbon bond only is there. Yes or no? Remember, here sp hybridized, sp2 hybridized, sp3 hybridized. You may know that sp, sp2, sp3. When 50% s character is there, the orbital is small in size. 25% only s character, orbital is bigger in size. So sp3 involved bond lengths are bigger. sp involved bond lengths are smaller. Now you pause the video and check which option may be correct for this. Can you? Here it is sp hybridized carbon and this is sp2 hybridized carbon. Here sp2 sp3. Here sp sp3. sp3 sp3. What I said? Where the s percentage is more comparatively, there the bond length is lesser. They're asking shortest here. So this is our shortest because here sp, sp2 involved. Double bond is there, no? sp, sp2 involved. Got it? If somewhere there is a sp and sp is there, suppose, that is further shortest. Because both are sp, sp means it's further shortest. In our contest, D is the one, sp to sp. You can find here Now you can find 25th question. They're asking for this molecule, they gave three canonical forms. Relative contribution means relative stability, which is more stable, which is least stable. I am saying many times that is a neutral molecule with all atoms octet configuration is more stable, right? Then next, if no octet like this C plus is there, has only three bonds around the carbon, three bonds, no octet here. Around this carbon also three bonds, no octet. When no octet is there, then between these two, which one is stable? Okay, it's very simple. When the unlike charges are closer, unlike charges are far, unlike charges are closer means more attraction is there between these two, and this is stable. Here attractions are lesser. Therefore, 1 greater than, 2 greater than, 3. You can check now. 26th. A very important model it is. And they mentioned here 1, 2, 3, 4 carbons. Carbon, hydrogen, second carbon, third carbon, fourth carbon, hydrogen. They're asking if it is homolytic bond dissociation, then which bond required more amount of energy? Got it? This is what our given molecule. Okay, here homolytic dissociation means you are going to make radicants. For example, this is broken, H radicand and Cl, C radicand. This is broken, H radicand and C radicand. Suppose this is broken, C radicand. This is broken, C radicand. So here, what basis we can tell which CH bond require more amount of energy? Remember, from where the H radicand if go, formed C radicand is more stable. From there easily H radicand will move. Remember this point. Okay. Now radicand stability. Who is more stable? 3 degree, 2 degree, 1 degree. Yes or no? So here, this is the one is a 3 degree carbon. If this lost H radicand, C radicand will form. Yes or no? This is what degree? Around this carbon, 3 carbons attached here. Therefore, it's easy here. Remember this point. Then 2 degree. If this is going as H radicand, now C radicand will form. So this is a second stage, second place easy. And primary, either this or this are primary. Breaking the CH bond is difficult. And both are primary means here who is difficult? Remember, if this radicand is formed here, next how many hydrogens are there? 2 hydrogens, we call here 2 alpha hydrogens. If this hydrogen is gone to this C radicand, next carbon has how many alpha hydrogens? 1 alpha hydrogen. So more alpha hydrogens if they are there, 2 alpha hydrogens are there. Now this is stable. So relatively first carbon, fourth carbon breaking is easy. Okay. First very difficult one is first carbon. Next difficult is fourth carbon. Next difficult one is third carbon. Very easy is second carbon because these two are primary, this is secondary, this is tertiary. Then your answer is this one. C1, next C4. It's easy because next carbon has 2 hydrogens that can give stability. C3, secondary. Very easy tertiary one because it has 3 and total 3 plus 2, total 8 alpha hydrogens are there for this. So easily formed. Which of the following has longest CO bond? See, if always double bond is there, less length. If it is become sometime single bond, then more length. When it becomes single bond, if it is more in conjugation, yes. So this has more conjugation here compared to here or here 2 pi bonds in extended conjugation. Therefore, it's easy, and this double bond is become a single bond here, and it is having more CO length. Yes, more conjugation, more length because double become single.